Bismillah ar-Rahman ar-Rahim. In the name of Allah, as we deploy the first course in Arabic, we got big request to have this course also in English version. So accordingly, we are going to start this course now. This course, the main target of that course is to provide what is the relation between mobile field and IP field. The main question we are going to ask in that course: is it enough to study IP purely without understanding the complete mobile idea? For example, I have IP engineer who can understand very well IP routing, switching, router switches, how router function, OSI 7 layers, all of that. Is it enough to understand the big achievement of mobile network today? The answer simply is no. Accordingly, we need to find out the relation. In this presentation, we would like to find the relation between mobile field and IP field, and what is the impact of development in mobile field toward IP field. That's what we are going to show in that presentation. As shown in the first slide, is pure example of modern mobile network architecture today. We have this network consists of main parts. First part called access part. This access part, which is shown as E node B above, or node B, this E node B in 4G technology. What is the main target of this access network part? Access network part is the main interface between mobile network and the end user. So mobile device, first point communicating with mobile device is access network. Then access network interface with the core network of the mobile. This core network consists of number of devices. Those devices depends on the technology we are using, if it's 2G, 3G or 4G. So if we take an example for 4G network, I'll find something called MME, PDN gateway. PDN gateway, for example, consists of S gateway and P gateway. Number of equipment communicating together so that it provide me services of mobile network, either packet switching or circuit switching. If we take the same example for 3G, we'll find some equipment called GGSN, SGSN, MSC, and so on. And finally, we have communication, for example, for the integration between 2G, 3G, and 4G. The main question here: how those equipment communicating together? What is the technology making those equipment communicating together? How access equipment communicating with core equipment? How core equipment communicating with each other? The answer simply is the main technology used for communicating all those devices together, it's called transmission. What is the transmission? Transmission is transmitting data from point A to point B. Simply, the first initial version of the transmission, it's called the legacy. It's called PDH and SDH, as we are going to show in the next slide. As shown in that slide, we are talking here about the legacy transmission system and why we moved forward IP. Okay. First of all, what is the main idea of transmission system? The main idea of transmission system, as we said before, we would like some information from one device to be transmitted to the second device. For example, I have something called media gateway, for example, in the core network, like to communicate with another equipment inside the core network as well. It's called MSC. How that communication happen? That communication need some transmission system. First transmission system we used to make that communication, it's called PDH and SDH. PDH is acronym for synchronous digital hierarchy. SDH is acronym for synchronous digital hierarchy. That technology mainly depends on TDM, like time interleaving, so that each customer has special time slot, and that time slot communicating from one point to the second point. That legacy technology, it was very static. If I'd like to make any communication, it's not very dynamic, it's not very flexible. So it has static features. It cannot have addressing from special source to special destination. So any configuration I'd like to do, I have to do by myself, by my hand, statically. It's not flexible, it's not flexible, it doesn't have any addressing system, so that I cannot change the source or the destination without changing the complete time slot. This is the first disadvantage in compared to IP technology. Both the creation and the interconnection was very complicated in PDH and SDH compared to IP, because IP has finally addressing for source and destination. So bandwidth allocation, it was very static. So if, for example, if I have point A to point B doesn't need that bandwidth, it's reserved for it, even it's used or not used, in compared to IP. IP has sharing resources idea. That's mean if point A to point B doesn't need that bandwidth and point C to point D need that bandwidth, it can be shared other than PDH and SDH technology. Quality of service concept, it starts to appear in IP, which doesn't appear before in PDH or SDH, which mean to differentiate between services according to bandwidth needs. For sure, adding and removing site in IP technology, it's more and more easier than PDH and SDH technology. For that, all those reasons, we start to move from PDH and SDH legacy technology toward IP to give me more flexibility and easy way to add and remove any sites. And after that, after we made complete progress in IP technology itself, we go to new technology called IP MPLS, as we are going to show in the next slide. In this slide, we are going to show the first real implementation for IP technology and its developing way, which called IP MPLS, which is the most modern IP technology, which is used in our mobile network. As shown in IP MPLS cloud, backbone cloud, this cloud making communication between all core devices. That means all core devices which we talked about before, which is related to, for example, packet switching, circuit switching, as we talked before, circuit switching, for example, something called media gateway, MSC. All of that communication happening using this IP MPLS backbone cloud. And accordingly, what about access network? Access network, as shown in the left side, access network making aggregation using still legacy transmission system till achieve the first backbone element, then making communication between access network and between backbone network. So progress didn't stop in that point, because we needed completely from end to end to be IP MPLS cloud. So first point we did here, we achieved that we converted our backbone from legacy transmission system toward IP MPLS network. Then in this next slide we are going to show the next step we did in that progress. As shown in this slide, we expanded IP MPLS, and instead of just one cloud, which called IP MPLS backbone, we expanded it toward our mobile network, as we did those rings which called IP MPLS backhaul clouds. Accordingly, we did integration between IP MPLS backbone and IP MPLS backhaul, as we are going to show in next courses. This integration making me simplicity in the implementation of IP MPLS almost end to end, from access equipment toward our core equipment. Then what about those clouds which called access 2G and 3G? Still, so far we still depend on the transmission. In this technology we depend on the transmission to making aggregation from access equipment toward the first backhaul network. Then in the next slide we still need to achieve the target end to end from very first access element toward core element, it should be purely IP MPLS, as we are going to show next slide. Finally, in this slide, we are going to show the most modern technology which is used today, which is purely IP MPLS network for mobile network from end to end. As shown here, I have my access equipment as shown in the last mile, which called PTS node B, E node B. It's completely communicating from the first point, communicating with one device which called ATN. This is the first cloud, IP MPLS cloud, called access network, as shown in left. Access for ATN, ATN cloud. This is the first IP MPLS cloud. And after that, this IP MPLS cloud is the first initial IP MPLS cloud communicating with something called aggregation backhaul cloud. Aggregation backhaul cloud integrating with access cloud, so that this is the first access is the first IP MPLS cloud, aggregation is the second IP MPLS cloud. Then after that, those two aggregating finally with IP MPLS core network. So accordingly, I have from end to end IP MPLS integration and IP MPLS pure network for mobile network. The question here, we realize now the importance of using IP MPLS and mobile and understanding both of them, so that we can highlight how to design, how to integrate, how to communicate between core equipment, access equipment, and mobile network. Thanks a lot for your interest in our videos. My name is Muhammad Qallawi, CCIE number 21068. You are welcome anytime, any feedback, any comment, you are welcome. Thanks very much.